I have a new friend. He's called Vector. Anki Vector or Anki Vector. Hey Vector, what's my name? Hmm. Hey Vector. Hey Vector, what's my name? Ah. Yes. Hey Vector, what's the weather?
5 degrees and raining.
So good. I'll probably make a whole video about him. He's programmable too in a Python SDK, which looks really neat actually. Let's test some functions here.
Someone's mother has 4 sons. 3 are named North, East, and West. What's the name of the 4th son?
Hey Vector. Thank you. So yeah, Python is not my strongest suit, but I can manage. We can bridge it to Java because the Anki Vector needs more AI. The hardware is great. It has everything I need right now. All the connectivity, all the sensors, everything. But it behaves a little bit like a slightly retarded child. It's not an insult by any means. It's fantastic. It's amazing. But I long for more AI in this thing. More speech recognition. I mean, they have the recognition, but they don't trigger many functions. And more speech output for sure. It makes all these noises all the time. Has lots of emotions, but there's not much in the way of dialogue. And it's a smart home central too. You can control your smart home devices through this, I think. Maybe the Raspberry Pi plus the Anki Vector are a great combination for a smart home. I will have to silence the little guy very soon, right now I guess, in order to get anything done. Hey Vector, go to sleep. I hope that does it. You can hold the button on his head for a long time, and then he will completely power off. Haven't had to do that yet. It's very cute. Got him since yesterday. Very happy. Okay, back to the hard AI task that we are solving. And I think today we're actually solving one of these challenges. It depends a tiny bit on what solving means. Of course, we're going to put in some little hints, some rules, make some rules ourselves. So it's not a completely automatic engine yet, but the manual part gets smaller and smaller. And it will really use a very small number of rules in order to get the result. And this it will generalize to more questions. Okay, so the architecture I propose has a few stages, kind of 3. We have any input, like this trick question. I'm not completely sure what the supposed answer is. It's not like these questions, the Winograd questions, that actually make sense. This one is just a trick, I think. So anyway, stage 1 we have is some pre-processing. For example, we turn someone's into someone space apostrophe s. That's just because the parser is much happier with this. That's pretty trivial, and we would fix like missing like typos. And the second stage is the parser. The parser takes the input and some, not even rules, just patterns. Patterns like very asterisk. or likes. That's all we want there. Later they're going to be refined and say what goes in here usually or whatever. But for now that's that. And outputs, groupings. And a grouping looks like this. 3 are named oh, by the way, open Twitch chat.
Open Twitch chat.
Three are named North, East, and West. So this is a valid grouping. And the patterns you would have used here would be this named, and here we could also further group whatever. You can always go into more detail with these groupings or stay on, or just do a few groupings. Okay, so the parser actually just outputs the same thing that was put in and adds some brackets, because that is what the next step needs, which is the logic engine, which is internally called philosophy bot. Takes grouped input plus rules and facts and outputs new facts, one of which will be the answer to the riddle. Yeah, that's how it's supposed to work. The preprocessing is pretty trivial. For now, for the examples we are tackling now, we have all the preprocessing done. Done. And stage 2, actually, I will declare done for now too. We still have to put in some patterns and stuff. It's not done for eternity, but it's done for the purposes of the challenge I do, the Winograd challenge. And this one is not done, stage 3. That's where we're going to go in today. Okay, brace for some hardcore AI stuff. Here's the playground window where we can play with this logic engine. And I have added a new capability to it, which is, I believe, very important. It is replacing inside of statements. Basic thing the philosophy bot works with is statements or propositions, just things, English sentences. But we often want to work on parts of that. For example, this adjective or adjective phrase, or however you call it. And there's a construct now called addSimplifier. And it has a rule inside of it which will be applied everywhere in this statement. Quite powerful. And already it did the job. I don't know why this should be empty. I am tired. Or this should be updated. Whatever. This down here is correct. I am tired. He was very keen. To get home. Okay. Keen to get home. Very good. You can also do the evil thing and rewrite with something longer. So it will keep making longer and longer facts. It will stop at, I think, 1,000. That's just a hard-coded limit. Well, it takes a while to get there, and yeah, there needs to be another mechanism that notices these endless loops. Oh, of course, when I reload, it will do the same thing again. Reloading is my way to stop it. Boom. I don't know why this comes up back all the time. This sub window is broken. Okay, now we have the working simplifier again. And yeah, because we want to simplify whatever we get in the question, of course. Some of these words are just not necessary to solve the question. How about this? Next one. Where do we paste it? We paste it here. Yeah. We want this multi-stage architecture. First, no, that was not that.
Eval.
Yes, thank you. Kind of here. Stage 1 is okay, stage 1B is the pre-processing, stage 2 is okay. Apply patterns to sentences. Yeah, just parse. That should also be okay. Now we just go to, let's rename this stage 3. Let's say stage 1 is the pre-processing sentences we also put in there. Stage 2 is parsing. Stage 3, logic engine. These are the parsed sentences. Yeah, Vector is very quiet now. It obeys commands. I don't know for how long it sleeps. Maybe it's gonna wake up in the middle of the video. Logic engine. What was this calculation? I don't even know. The annoying thing is we have multiple sentences and we want to do each at a time. No, we do not want to do each at a time. Of course, the logic engine needs to think about all the sentences. Yeah, sure. Here we have the parse tree and we need the grouped output actually. It's a list of strings. Yeah. I want to make a convenience function that parses and gives us the groupings. Parse to groupings. Voila. There's that. Parse to groupings. Oh, what's the... Oh, this is another example that we're using here. Yeah, whatever. We can go with this one too, doesn't matter. So Bob and Charlie as the new example. Bob and Charlie. Result of the multi-stage processing. Something went wrong here. Yes, just a little bug. Let's do it again. Here. And there should be some nicer output here. Yeah, the 3 sentences and all questions that we put in. Yeah, here's ungrouped and this is grouped in a very good way. Who is generous? That's just unchanged basically. And the first one has multiple interpretations. These are, I guess, 3. No, one's ungrouped and 2 grouped interpretations. It's a nice and small number. The first one is the really good one. Okay. So, well, we want to see what's happening, so I think we should actually use this playground window to make it more visual. Yeah, let's make a new one of these 10 to 6, 10 to 6, 3, 7, 3. How do I operate it? Oh, I just set the text and that's it. Make philosophy put text playground. New show maybe with the program inside. Show new module. Should work on my posture. That should do it. Yeah, what's our program? Our program is basically just what the parser put out. We just paste the whole thing in there. Something's gonna stick. The logic engine doesn't mind if there's more stuff that it doesn't recognize. If some facts don't match any rules, they just do nothing. Just sit there. Yeah, let's just use all of them. All groupings. Grab them all. Concat 2. Wild guess, no. Concat lists to case insensitive set. have number x of groupings. And we just paste them in there. Cool enough. Let's try. Not list, but iterable, because iterable is the more general type. Aha. Aha, not bad. Oops. Not bad at all. So, these are the facts, and the question, it's in there twice, but it's not really important. And I mean, we could just throw away the question mark and have it a little cleaner. In the interest of beauty, maybe we'll do that. Drop question mark. Drop question mark. Exactly. Try again. Yes. Now only one of them remains. The other duplications are okay. They're actually wanted because the parser is not sure how many brackets the logic engine needs, which depends on the rules and stuff. Okay, now we need some rules and the thing will come alive. And for now, yes, we make the rules ourselves. Later, AI will start to make its own rules. And when it's completely able to do that, we will have an autonomous AI. That's a gradual path, right? From something that's very manually coded, to something that is learning in part, to something that is completely learning. And we just follow that path. Some people say you have to make a complete learning machine instantly. If you hard code anything, it's like wrong, it's bullshit. Even a neural network has hard-coded code. The structure of the neural network in the algorithm is hard-coded. A programmer made this. So no neural network is completely self-defined. And the amount of work is quite big. Making a neural network is such a black art and can go wrong in so many ways. There's a lot of human expertise inside of it. Okay, that was a side note. Back to this. Where are our rules? We have some rules loaded already, which are kind of useful. For example, who is and yeah, this answers the question. Okay, the thing is, this rules list could be long. It needs to be filtered, which is another task for the question at hand. That's one task we have, and then we just apply the rules. Basically, it's the one important task. Selecting the rules for the current task from a big pool, that is the central task, actually. Because the rules are good in of themselves, and they will interact in strong ways when you combine them. So putting in too many rules can be dangerous, can lead to these endless loops like we saw, and could actually be wrong. Some rules don't always apply, which is another thing that has to be learned. And too few rules means that the solution is not found. So you need to choose the right rules for the job. That's very important. Actually, we could put this in here. Stage 3A. Select rules for the task. We just say rules equals magic of task and we're done. Had a good laugh there. Okay, let's do the funny thing and just put them all in there. Function is called getUnclearList. Rules, all rules. Do we get a list? Do we get a set? I don't know. It's a collection. And let's put in all the rules. Take all for now. Oh, do we have that? All groupings, all rules. And just go for it. Yes. Ah, facts deduced who. That's a great fact. Okay, the question is who is generous, right? Here. And yeah, let's do something here in an editor that doesn't, in a dumb editor. Sometimes I want text editor that is just storing my text, no AI attached, no anything, just like a piece of paper. This is my virtual piece of paper, conceptually. We have to put in some facts about life. That's the way to progress. Generous people pay for other people's things. Needs. It's so pretty complicated because this involves two people and stuff. We could have a simple rule: generous people pay, and this would. It's a fact, actually. A fact. From the fact comes a rule. X pays for something. X is generous, and this will actually, I think, solve the thing immediately. Just with this one little trick. I think if we put this rule in here. No, didn't do it yet. Let's see. X pays for Y. Oh, pays, paid. Yeah, we have this time issue. You know, past tense. That's another transformation we have to do, it's true. But it's not the hardest thing in the world. It's a little bit hard because it needs to put into context the structure. Boom! It's actually, this is done now. Did we use any of the other rules that, this is obviously from another, this is wrong anyway, and this is from another question, because I just took all the rules that I made recently. And I think we don't need any of those, actually. We need, in effect, yeah. I mean, we have two outputs here. No, this is okay, it's a fact. It would be nice to say the answer of the question is like this. Do I have something like not equals? Let's see. X is who? Nope. How do I say? I forgot what I put in here. This is a language I made up myself. This logic programming language, and I kind of forgot which primitives I have. I just want to say that if who is the answer, that's not an answer. How do I do this? Let's just find it. It's important, I think. It has different like libraries. There's a math library. We can say number is greater than a number and stuff like that, which is almost what we want. Bool. Okay, that's just a true predicate. That's not that much. Yeah. Let's put it in somewhere. We have to add it, it seems. Take this as a template. And bool is a good fit. Equals. And I use the ignore case thing because I just like that. In fact, here there's a shorter syntax. $x of map, $y of map. Why are there brackets here? Nobody knows. Yeah, this could be something. Oh, no, yeah. No number parsing, just taking this literal strings. Okay. Sorry. To retranspile something. And also I used the other version. Does not equal. Now I'm curious. Is this gonna work? It may work. No, why not? I believe standard imports might help us. No, it doesn't. Okay, this needs more testing. For now, we'll have to live with the fact that we get two answers, one of which is not very interesting and the other is. Okay. I mean, how about something elegant like is a person, X is a person, and let's just put it in here, but Bob is a person. And to be sure that we are not faking it, we put the other person in too. Run the whole thing again. We have this in here, we have this in here. Okay, I just need to copy this into the rules. Yep, and run it yet another time. Too many windows. Okay, I'm confused with all my windows. Let's see. Here. Yeah, one stupid thing is that here I cannot edit. I have to make an edit command here. Oh man. So that I should do that in a second, I think. Low-level coding, what can you say? I wanted to put this in here. The answer is $x. And we said $x is a person. And now we have it. The answer is Bob. The question was, who is generous? The answer is... It would be cool to see the question like more prominently all the time. That's just cosmetic. So the answer is Bob, because Bob paid for stuff. If we take the other version, these Winograd questions have two versions. Generous / grateful. And the second version has a different answer. I should make this one button though. I could cut it out of the YouTube video maybe. I don't know. Unclear list. I have to make this edit button. Edit. We get something selected. Yes, entry. If there's nothing, we return. Edit. Oh, it's not that bad. Add item, no. Set the name. Set the comment. And notify the persistence engine. Yeah, and why don't we just make delete also, then we're done with this. Delete. Remove selected. Ha. Stretch the old bones. Stretch the bones, whatever. Yeah. Okay, this one was bogus anyway. Delete. That worked. And oh, I have a nice idea here. Who is, oops, Okay, here. Who is the question? We want to say X is a person. And when we've done all this, how about this? The answer to the question is a person. Oh, the answer to who is generous is Bob. And this time I didn't tweak anything in there. I just made smart rules, which were then applied. I need like an ergonomic chair stuff. Yeah, the other version. Winograd take. Let's take the other version of the question. Take second option. Second option. And in this monstrous regular expression, we just move the brackets. Boom. That should be that. And oops. Take second option. That's not going to work because we need one or two more rules and then it's going to work. Also, I messed up the regular expression. Who would have thunk? Who would have thunk that I could mess up regular expressions? So straightforward, look at this. How can you mess this up? It's impossible. I think I fixed it though. Looks better. 50 milliseconds of computation time. Bob is generous, but it's not what the question was. The question is, where's the question? Who is grateful is the question. And, you know, the fact if someone pays for your needs, you are grateful. That is a fact about life. Usually, out of which we make a rule. X pays for $y. Need. And let's say they're not the same person. Then the receiver should better be grateful. And we just put it in the past tense too. And we are, very curious whether this will solve the question. No, it didn't. Oh yeah, because, okay. The thing is, we should also put these rules through the grouping, through the parser. I hadn't thought about that, but that's also a part of the puzzle. For example, if we put this in the parser, let's see. It doesn't matter that these are variables that the system knows nothing about. It still applies the patterns. And here's already a good... No, wait. Yeah. I think this should do it. Let's... Wait, what was the problem? The problem is that college education is not in brackets in this version. Okay, let's add one more step here. Group. Nobody said AI would be easy. Because if we just do this here, I think we have the thing. No, not yet. We also need a good way to debug this, of course, to see where something goes wrong. What if we remove this? Okay, now it works. So what was the problem? Oh wait, standard imports? No. Okay, Charlie is grateful. This is what we wanted to get, and we got it. And clearly X and Y are not the same here. After this has been matched, X is Bob and Y is Charlie. So why the heck would this not match here? We can just put a debug statement in here. Just a quick hack. Because I want this to work, man. I want this to work. Print equality check. Equality check. Coffee check. Still some coffee. Vector is still sleeping. Failed. Yes, 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 yes. Yes, 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 yes. I am so sorry, dear computer. I am sorry for all the typos you have to endure. Okay, it does not perform an equality check. Which is crazy. Come on. 5 equal... Oh, I have to import, I think. Standard imports? No, I have to actually do it. Hold on. Yeah, okay. Okay. I forgot how my own mini language works. I think maybe this is not even... Yeah, okay, just import bool. Duh. Remember your own language, that's good. Okay. Yeah, that was this actually.